Welcome to the ARM Developer Summit, and thanks for joining this campfire session. It's about ARM development made easy in the cloud. This is a live session, and it is being recorded. My name is Manish Kapoor, and I'm from the Oracle Cloud Infrastructure Product Management team. I'll be the host and moderator for this campfire session. In this session, we'll discuss how ARM, Ampere, Oracle are making it easy to develop applications on the server side in the cloud. ARM processors are everywhere in mobile devices, IoT sensors, smart TVs, and most consumer devices that you use today. Now this technology has evolved to support laptops, servers in hyperscale data centers, and cloud computing. Apple, Oracle, and Amazon are among the first companies to bring ARM processors to the cloud servers. Today in this session, we'll talk about the ARM compute platform in Oracle Cloud and the developer ecosystem available to help you seamlessly transition, build, and run ARM64 applications. Our panelists today are Peter Polliott from Ampere and Sanjay Pillai and Brad Kelman from Oracle. Thanks for joining us today, Peter, Sanjay, and Brad. To our audience, thanks for taking the time today. And let's make this an interactive session. Let's keep the questions coming in. There is a Q&A functionality within the event page towards the bottom of your screen. You can post and submit your questions to that event page. If we cannot answer all the questions that we received today, we will definitely respond to you later directly after the event. And after this camp session, if you'd like to continue to engage with us or connect with us on LinkedIn or Twitter, our handles are shown on this slide. So let's get started. The first question that I have is for Sanjay. Tell us about Oracle's ARM-based compute platform. What is it? And tell us about what are the offerings that you have in terms of ARM compute on Oracle Cloud Infrastructure.
Thanks, Manish. Hi, folks. It's really exciting to be here and virtually speaking, unfortunately, in the world that we are. But thank you so much for that question. And let's start. It's a broad question. I'll try to do it justice in a couple of minutes, and then we can drill into more details as folks have more questions. So very broadly speaking, what we enabled in May of this year was
Sanjay, can I pause you for a second?
Sure.
I'm getting a question from one of the folks on the attending this event that they're not able to hear us. So can we check from the ARM team, events team, can we check to see if the audio is going through correctly?
I can hear everything if it's any help.
Yeah.
Okay, the audio is going through. I just got the confirmation from the ARM team. So thanks for that, for the events team. So keep going. Sorry to interrupt you, Sanjay.
No worries. I think that's a good interruption. So in May, what we did was working with Ampere, we introduced the OCI A1 instances, both in virtual machine and bare metal form. This is built using the Ampere Ultra processor. And what our goal here was not only to introduce the hardware, but also the platform and the ecosystem around it. So very quickly, what we enabled is on the bare metal server side, you have the ability to scale all the way up to 160 cores of ARM, which is the highest you can get in the cloud today, that leverages the Ampere 80 core CPU. And then what we also enabled is flexible virtual machines on Ampere A1. And that allows you to right-size your VMs all the way from 1 core to 80 cores and between 1 to 64 gig per core. So you can adapt your workload. So you can adapt the virtual machines to your workload. And in addition to both VMs and bare metals, it is also something you can make use of with our managed Kubernetes service. And this is coupled with a range of platform support that we have, everything from Oracle Linux and Ubuntu operating systems to the Java, Graal, and our partnerships we have with folks like Genymotion and others that we're continuing to build on. So I think the combination of all of these things, the hardware, the platform, and the partnerships are what we're trying to do to make using ARM in the cloud easy and to enable you to port and bring all your applications over. One last thing I will say, though, is that in addition to our sort of simple everyday pricing with a penny per core or 1 cent per core hour and 0.15 cents per gigabyte hour, we also have this always free 4 cores and 24 gig, which we have introduced, and that we've seen a huge demand for that. That's been exciting to us. And this is part of what we're also trying to do to make, as you put it in the beginning, Manish, ARM development easy in the cloud. So I'll stop there for now.
Okay, thanks, Sanjay. So I'll come back to you on that Flex VMs. That sounded interesting. So I would like to dig in a little bit more about the Flex VMs. But let's get to another question that has popped in. And that's for, I think it should be best answered by Peter. So we are using Ampere Altra A1 processors as in the A1 compute, as Sanjay mentioned. Can you tell us a little bit more about the Altra processors? I heard and I know for sure that these processors, unlike the Intel and x86 processors, they're not hyper-threaded. So can you tell us a little bit more about the Ampere A1 processor and why you choose the single-threaded design and elaborate on your design decisions?
Absolutely, Manish. Thank you. And thanks for having me, folks, for in this session. So essentially, just a little high-level background is, Ampere decided to architect its chip specifically for cloud-native workloads. And as such, we had the luxury to be able to, make some decisions in terms of, how we want to lay out the structure and the core count and things like that. As we all know, there's been problems in the industry with speculative execution and hyper-threading, and carving up the cores, leads to potential security issues. So because of that, one of the choices that we made was to make the Ultras have a single thread per core. And obviously, as you can tell by the core count, with the Ampere A1, we support a higher number of cores rather than trying to, segment or cut up the core into individual threads. So, because of that, it gives us an extra barrier of isolation, right? Because we can pin to a hard core and then just provide, more cores and a more highly efficient, core dense platform, right, which is more suitable to cloud native use case and environments, right?
Yep. So I think it makes sense in a multi-threaded cloud native environment that we are typically using these days in every cloud provider. Having single threads gives not only better isolation, but a logical separation of workloads between threads. Right. So perfect. Thanks, Peter. Let me see if I have other questions. So I have a question for, again, back to Sanjay. So what type of workloads are suited for ARM Oracle instances? And do you have any performance benchmarks to share about what you have done, on Ampere A1?
Thanks, Manish. Actually, by the way, Peter, I don't know if you intended to say that. I liked how you were talking about the pinning threads to the core, and you used a phrase like, it was like a hardcore. I think that's what we should start calling this right now, hardcore, right? That's a missed opportunity there, Peter. Okay, so let me go back to the question that Manish had. So when we designed the A1 instance, and the way we are offering it, both in terms of bare metal VMs and managed Kubernetes, we did this very deliberately, right? What we believe is that the A1 instances and ARM in the cloud is what's going to be sort of if you will, a first-class citizen, right? We have intended and designed our A1 instances to apply to a range of workloads, everything from your regular web servers, your middle tier, your applications, your SaaS workloads, all the way through to in-memory caches, databases, media encoding, encryption, and then even opening up new avenues for ARM native workloads, partnering with some folks like Genymotion on Android development in the cloud. And so the way we designed this is to offer all the same capabilities on A1 that we do on the rest of our x86 platforms, right, Intel and AMD. So we are essentially treating, for the way we're positioning this to our customers is now you have the diversity of multiple options, and then you can choose one that best fits, that provides the best price performance for your workload. And working with ARM, we have benchmarks that are published on our site in the links that Manish brought up, and we can share this again at the end. We have benchmarks on web server workloads, as well as benchmarks on media encoding workloads that demonstrate how, both in terms of performance, but especially price performance, the Ampere A1 really demonstrates value as compared to what traditionally you're using on x86 workloads. So I think the way I'd sort of sum up there is that this is ready for all of your workloads, and we are excited to see what customers and developers have already been started to port over. And one of the questions that, the interesting comments that we get is sometimes when people use Ampere A1, often the question I have is like, what help do you need? And most often the question is, the response that comes back is it just works. And that's really exciting for us. And that's really where we hope that more and more people will discover that ability.
Okay.
Can I add a little bit of that? Manish, can I add?
Sure.
Yeah.
Sure, Brad, go ahead.
So I think, one of the things developers should think about when they're looking at workloads, it's really exciting, is something Peter and Sanjay both mentioned. This single thread per core has two major impacts when you're looking at workloads. One of them is cloud native, right? This is the idea. Single thread per workload allows a large scale out computing. You just keep deploying more cores and more cores, and that's the way cloud works. The other thing about the single thread per core that's maybe not obvious to everybody is because it's done that way, the chip actually has, each of those cores has a dedicated resource. So for instance, when you have a thread running, it has a memory that it's not sharing with other threads because of the resources assigned to that core. So you get better predictability, you get performance that Sanjay said shows up in the numbers, and you get major scale out. So these are huge advantages when developers are saying, what makes sense to deploy on A1.
Yeah, that's a really good point, Brad. Right? I think to just add on to what Brad said is one of the things I didn't touch upon was one of the benchmarks that you see, or one of the things you see when you're testing on CPU-intensive workloads is how, as you increase the number of threads you assign to the workload, the almost near linear scaling you get for these kind of intensive workloads. That's a good point, Brad. Thanks.
And if I can make one comment too, specifically about Sanjay's point about the software just working, right? Like we really have to pay tribute to those who came before us to ARM themselves to things like the Raspberry Pi movement, driving awareness and a lot of, momentum to get the software into the place it needs to be, right? And I know, myself, who does a lot of sort of greenfield outreach to different open source projects, the raw enablement of moving, of helping projects, one, adapt native compilation for AR64 workloads, as well as, moving into server-based AR64 compute. A lot of times that's playing with Ampere ones and Oracle Cloud might potentially be the first time they get to experience a server-side computing of that, on AR64, right? So,
Yep.
There's I think a lot of credit to the folks who started before us. We still definitely have a way to go, but to your point, there's, I'd say, a good portion of the existing open source software that exists today should at least function, if not, perform better than you would expect on ARM as a result of the work that was laid out by our predecessors, right?
Okay, thanks, Peter. So once again, a reminder to our attendees, we'd love to get more questions from you. I would love to get some tough questions for the three panelists that we have today. You've been putting in some easy questions. Let's put in some tough questions as well. I have one more question here, and that's for Brad, taking it a little bit further from where Sanjay and Peter left. Sanjay talked about the OCI compute platform for ARM, the Ampere A1 platform, the flexible VMs. Peter talked about the Ampere processor and the design decisions for Ampere processor. Can you talk a little bit more about what is there on top of this platform and the processors that are available for developers in terms of working on, whether they're working on open source or well-known applications like Tomcat and MySQL? Are they ported? All these software? How's the software developer ecosystem look like?
Yeah, you could probably get me going for an hour on this.
You got just 3 minutes.
Yeah, we really worked hard to try and make sure that developers come in and they have everything they need, not just some things, not just a tool chain, but like the complete tool chain. So we did a lot of things to put this in place, to put everything in place that developers will need, from OS to languages and to make and then code packages to run on top. And make sure that the support is there. Make sure that the developers have a way of finding out that the support is there through, for instance, the Ampere developer portal. Make sure that they can find the information through the ARM developer portal, from OCI ARM developer portal. And then we also partner with your favorite technology providers. In CI/CD, we're partnering with Jenkins and GitLab, and in monitoring, we're partnering with Datadog. Mobile, we're partnering with Genymotion, and cloud native would be something like Rancher and Nginx. So we're partnering all over the place. But if you want to get started, what I'd say is go get a free account. We give you tons of free capacity. You get 4 cores, 24 gigabytes free, always free, right? You can get 200 gigabytes a block with your free tier. How much is this? You could run a small company on this. You can spin up 3 node pools, 1 for admin, a couple of blue greens, still have enough resources left to run a web server like WordPress and like a small database like MySQL. This is 4 times the number of cores you can get for free from our competitors. And those of you that love Raspberry Pi, which is really cool. But think about this. When you go to our free tier, you get the same number of cores as a Raspberry Pi 4, but you get way more memory. You get 3x memory in the A1 shapes.
And now, the only thing the same, Brad, is the count.
Yeah.
From a performance perspective, it's quite different, right?
All right.
Right.
All right. Thanks, Brad. So I see that we have a bunch of common developer tools that are available for every tools that are most popular among developers, like Jenkins, GitHub, GitLab, monitoring tools like Rancher and things like that. Kubernetes support is there on Ampere A1, so that's pretty good. Let's people start easily and quickly. I did get another question, and I think I'll put this question across to Sanjay. So when do you expect other Oracle applications to be ported and optimized for ARM. And I think one of the big ones is Oracle database. Do you have any insights? And I'll give you 1 minute to answer that. We are nearly running, coming to the end of this talk. But I have one additional related question for you. So can you also talk about what's next for the A1 platform? What is Oracle planning to do with the A1 platform going forward?
Okay, so so you weren't lying about the hard questions. There's a range of Oracle applications that we enabled at launch itself. Everything from Oracle Linux, Java, Graal, obviously MySQL. So a lot of these have already been there for ARM, and we tested them and qualified them on the A1. There's a range of other Oracle applications, including Oracle Database, that are currently in development that are working to port on ARM. Unfortunately, I can't share any of those dates right now, but please do reach out to me if there are particular applications you're interested in, and follow our pages to get updates on when we're doing. So you will see us kind of continuously rolling these out as these applications get ported to Ampere A1. So not a terribly exciting answer, Manish, but more to come.
Okay, thanks. Peter, yeah, go ahead, Sanjay.
There's one more question I saw in the chat from Padma, asking about shedding some light on complexity in the hypervisors. Very briefly, Padma, what we do with flexible virtual machines is about enabling you to choose the kind of cores in memory, but we do this on all our VMs today. So we essentially manage the complexity of placement on the hypervisor and adjusting that. So that is something that you are right is complex, but that's what our engineers have done a lot of hard work to enable that on the back end. So that's something that you get the benefit of, and that's part of our philosophy about making things easier for our customers.
Okay, thanks, Sanjay. I hope you can hear me because I had some little bit of a hiccup in my audio system.
We can.
Thanks. So I think one last question and then we'll wrap it up is for Peter. Can you give a quick 1 minute, insight or sneak preview as to what's coming from Ampere side in terms of the ARM development, ARM processes?
Well, a couple things, I guess, to tease on. We announced publicly, I think it was in June, about us, working on our own core for our chips. And obviously, both with Ampere Ultra with its 80 cores and now our Ultra Max, which is new to the market with 128 cores, I think you could always expect high density processors to be coming out of Ampere. So yeah, stay tuned for more new and exciting things for us for the future of your cloud computing.
All right. Thanks, Sanjay, Brad, and Peter. We are almost at the top of our session time. So this concludes the campfire session today. Thanks everyone again for joining today. And we look forward to working with all of you and the ARM community and growing this ecosystem together. Have a wonderful rest of the day and a wonderful ARM Developer Summit over the next 2 days.